Okay. So we've got two functions. One is 1 over x plus 3. We've done those kind of graphs in Chapter 2 as well. It's going to have a non-permissible value at -3. It's going, no, nothing's canceling out, so there's not going to be a hole. But if you look at the highest powers of x, there's going to be an asymptote at y equals 0, horizontal asymptote as well. So this graph will have an asymptote here at 0, 1 at -3. When you plug in 0 for x, you get a y-intercept of 1/3. This section will go like this. You would have to plug in a point over here as well. Excuse me. That would look like that. For g of x would be x squared minus 4x. It's a parabola. If I were graphing that parabola, because it's not in standard form, you could complete the square to get it in the vertex form, so you could graph it. For this one, though, I would, if I wanted to graph it, I'd probably factor out an x so that I could tell that I have a x-intercept at 4 and an x-intercept at 0. So my parabola, it's positive, will be going up, would look like that. So those are both my separate functions. We didn't need to graph them. It didn't ask us to graph them in this equation, but it's just a nice review because you're going to have to graph a fair bit on your final exam. Now we want to find an explicit equation for g of f of x. So instead of f of x, I have 1 over x plus 3. Now, g of x says wherever there's an x, first that number gets squared, then you subtract 4 times that number. So what that means here in this case is this will first get squared. Then you're going to minus 4 times that number. So this would be 1 over x plus 3 minus 4 over x plus 3. If I wanted to make this one fraction, sort of what we have to often do in our Chapter 7 identities, was get things to be a single fraction, I would need a common denominator. I could do that by multiplying the top and bottom of this one by x plus 3. And then I would have 1 minus 4x, minus 4 times the 3 would be minus 12 over x plus 3, x plus 3. And if I wanted to simplify that, it's going to be minus 4x minus 11 over x plus 3, x plus 3. From our Chapter 2, can you see that we have a non-permissible value at -3? So there's going to be a vertical asymptote at -3. We also have a highest power of x squared. We have, because if you multiplied this out, this would give you an x squared on the bottom. You have 1 x squared on the bottom and no x squareds on the top. So you will get an asymptote horizontally at 0. And you have an asymptote here at -3. And this is one of those crazy graphs that actually goes through the can you see when is this equal to 0? For the x-intercept, we find an x-intercept when the top is equal to 0. Again, this question didn't ask for all of this, but it's such good review. 11 over -4. So we do have an x-intercept. -11 over -4 is almost negative 3. There is an x-intercept there. Our y-intercept, if you plug in 0 for the whole thing, you're going to get negative 11 on top. 0 on the bottom will give you 3 times 3, which is 9. So negative 11 over 9 will be our y-intercept. And they're not going to give you one like this on the final exam, but my guess is it looks like this here. Approaches that asymptote. And we'd have to plug in one value to the left of this to figure out if it looks like this here or if it looks like that there. My guess is it looks like that on the bottom, but I'm just taking a guess. Yeah. Maybe not. I think it'll be on the top. Doesn't matter. We could plug in a value to find it out. Now, for a question like this, if they do give you a graph like this, it'll be on a calculator section, so you could check it with your calculator. And then if you wanted to find the domain of this, well, the domain you don't need a calculator. For the range, you definitely would need a calculator. But the domain, can you see that it's everything except for x equals negative 3? So when we write our domain, we can say x can't equal negative 3. And that would be enough to also assume that everything else is fine. I'm going to leave part B for you to do. And the question 6D, we might actually do that one together a little bit later, but we'll go on to example 3.